Welcome everyone. And today let's look at a non-traditional math question, or at least not a question that you normally study at school. The question is a little bit long, so let's read it together. We can see from this figure that we have 25 little squares, and they are arranged in a way that form a big square. Each room is said to be connected with another room when they share a common edge, not only a corner. So for example, if we pick this room, then we have three choices to go through the doors is this one, and this one. And now our goal for this question is to visit every single room exactly once and return to the room that we start from so that we can enter and exit from the same room. And the question is, can we reach this goal? Okay, so if we want to solve this question, after we read this, the first impression is probably like, I don't know where to start, right? So let's break it down first. So consider if assume we can reach this goal. That means we should be able to mark every single step on our graph. And if we cannot reach this goal, that means probably I have to show every single possible route that won't work. This seems very complicated. And obviously, this is not going to be an approach that we're going to solve this question. So at this point, I would suggest our audience to try to solve this question yourself first before we're going to reveal the answer in the later part of the video. But I will offer a hint. Let's say think about even and odd numbers. Or to be more detailed, that we probably want to classify our rooms or the 25 rooms, then I can use them to represent as even and odd numbers. Okay, now let's solve this question together. You can see the actual solution for this doesn't really involve any calculation or a little bit calculation. And then this question is actually a perfect example to show that simple logic can help us to solve a question that seems impossible to solve. Okay, the first step, we are going to color these rooms like a chessboard. All right, I hope you know what this chess is. So each squares has a alternating color, has a different color than the squares next to it. So let's color some of them into pink rooms and leave the rest to be the white room. Okay, so this is a very simple color. I just draw a pink cross on it, indicated there are pink rooms, and the rest are white room. Now we can pick any room we want to. For example, let's pick this one. Right, let's say this is a room we entered. Now we can also make a list to record it where we start. So our list will start with W, indicated as white. And then we can see for our next step, no matter which room we want to enter, it must end with a pink room. So we're going to write a P to indicate it. After the first choice, we're going to end with a pink room. Let's just say we just choose to go to this one. Now we're here. And now we can see the same question is no matter which choices we're going to choose, we are going to end with a white room. This is also the reason why we want to color this, our squares or the rooms in this way, so that we are making sure every step Let's mark it here. Our color, the room color will change. So let's make the list a little bit longer. And we know it is going to continue. And now the question becomes, where are we going to end? Right? Now let's go back to to look at our goal again. Our goal is want to visit every single room exactly once and return to the same room. In order to reach that goal, we need 25 steps because we have 25 rooms. So in order to go back to this, we do need 25 steps. So as our hint mentioned that we are thinking about even and odd numbers, 25 is an odd number. So when we look at our list, we're going to focus on the odd steps. So let's mark our steps. 1, 2, this is 3, 4, 5. And we can see the odd number steps are this one, and then this one from our first few examples. And we can see no matter which steps, as long as it's an odd step, we will always end it up with a pink room. That means if this number is 25, the result room we're going to enter is going to be a pink room. However, our goal is we want to return to the same room we entered, which is a white room here. Then we're going to end it up with a contradiction. Because if the room color is not the same, how can I be ended up with the same room? Right? So if we have an odd number steps, we always ended up with a room that has a different color as where we start from. If you don't believe this, you can try to start with a pink room, and after 25 steps, you're going to end it up with a white room. Therefore, we can see that we always have this contradiction. That our goal will never going to be reached. And therefore, we can show it is impossible to do so. And that's it. Hopefully you like this question. Thank you.